Hey, I'm Don Sackett from SciAps, now a subsidiary of Malvern Panalytical, but we're here still cranking away on portable analyzers. I'm here with my favorite chief scientist, Brendan Connors, today.
Hello.
So, all right, so we are here to talk about your great RoHS method. RoHS, we moved over to this device. So let's give a quick history of this device. As you were with me 15 years ago at our last company, we saw the RoHS boom with XRF testing, as you recall. And you did a great job making all that stuff work. But remember, they were buying tons of handhelds, and it seems like over the years, the industry has moved away from handheld XRFs to benchtop XRFs. I think it's because they want something a little more stationary that won't walk away. You know, maybe with a bigger chamber, an interlock chamber for more safety. That's what we've been hearing.
Yeah, fully shielded too.
Fully shielded, good point. So anyway, in response to that, we've taken our original powerhouse XRF device, which was originally meant for rare earth metals with a much higher X-ray beam energy, and we've reconfigured it with our RoHS hardware that this guy has been so instrumental in. So what the result of all that is what we call this portable benchtop. So this is the system. It weighs about 15 pounds. It's battery operated. You really can't see that over here, but it's got two batteries in there. When one battery dies, it automatically switches to the second battery, so you can charge that one. And you can also run it at AC power if you're stationary. It has a nice lid. It has a leaded glass window. You can see your sample at all times. It's interlocked, so if you open the lid, it shuts off the X-rays immediately, so it's very safe. It's got a mechanical lock, because if you do want to pick it up and carry it around, you just pick it up and carry it around. You take it around, take it to any place you need to take it, put it back on the table. All right, it's very rugged, and we can start some testing. So that's the system. What else do we need to say about this? You think of anything?
Yeah, I mean, the software, it's the same great RoHS software that we have on our handhelds, just put on the tabletop benchtop analyzer with a much brighter screen, bigger screen, 7 inches display, so it looks beautiful. You can see the sample as well as the results side by side.
Yeah, it was good of you to be nice to Katarina about that.
Of course.
Yeah, of course.
She does a great job.
He also has a 3mm beam spot. So it's got 3mm spot, it's got a camera, you can look at your material, so it's got a targeting circle so you know what you're hitting. So if you're looking at like a toy where you want to see just a small area of paint for RoHS compliance, is there lead in the paint or not, it'll allow you to do that. So you can use it for CPSIA compliance as well, right?
Yeah, any restricted metals, so lead, cadmium, mercury, and we can add additional metals to it as well.
Okay. And all right, let's run some samples. What do you say?
All right.
At least a couple. This is a nice polymer sample. You put it in, shut the lid, and you hit start. And the first thing it's going to do is it's going to say, is this a plastic or an alloy? Because it's a different calibration. So when it comes up with a plastic, you see in just a few seconds, it's already said, okay, cadmium is above 100 ppm, so that's already a fail. Bromine is kind of inconclusive around 900. But anyway, it'll run how long does it, what's a typical test of length?
Yes, we have it set to 30 seconds on 3 different beams, 3 different exposure settings. But it's totally customizable. You can run 1 minute, 2 minutes, sort of whatever accuracy and precision you want from it.
Yeah, excellent. So there's a completed test. This would be a fail because cadmium is greater than 100 parts per million. That's really all you need to know. It does detect chlorine, as you can see. So if you're worried, is it PV? Is it halogen free? That's another one, right? Halogen free or not. It'll see chlorine, it sees bromine, and that's really the system. Let's run, let's show one more thing. So if, let's say I'm doing a test, and let's wait till we know it's running, I say, okay, just open the lid, and immediately it shuts off the beam, says scan failed, test chamber interlocked, open. So that's prevents anybody from just opening the lid and getting any exposure to X-rays. Let's run a metal sample, a copper alloy. Here we go, hit the start. Same thing. Determines first is it an alloy or polymer or some like mixed sample, and now it's running the test. But you'll see, it already knows the cadmium in just a few seconds is 23 ppm or around 20 ppm. So it already knows that cadmium is less than 100, which is the RoHS level for cadmium. So that's really very fast for measuring cadmium in an alloy. Anything else? What do you think? It's just runs along, does its thing?
Yeah, great detection limit, so we can do single-digit ppm cadmium in many alloys, like brass alloys below 10 ppm, low detection limits on lead, mercury, chromium, because it's running the multiple beams. And auto sample ID applies different action levels based on what kind of sample you're testing. So based on the guidelines, it's either polymer, alloy, or mixed sample. It's going to apply the appropriate action levels to say if it's pass or fail. And you can add action levels for additional elements if you want to.
Yeah, excellent. What do you think is the detection limit for cadmium in plastic?
Maybe 2 or 3 ppm.
Okay.
Yeah, really low.
Because at one point, even though the regulatory limit was 100 ppm in plastic, people wanted less than 10, less than 5, so this can also do that, right?
Yep, yeah, so that's, for if you do a test for like 1 or 2 minutes, yeah, you should reach that, barring any major element overlaps.
Yeah, anyway, excellent. All right, well, that's the system. It's a great little system. It gives the industry the benchtop they want. It's interlocked. You can see the sample. It's got a collimated beam to 3 millimeters. It's still portable if you want to carry it around, and it runs off dual batteries, so you'll never run out of battery life, and you can charge it up. And you can run it on AC power, and at the same time be charging the batteries if you want to do that. Big, nice display. That's the system. So
yeah,
good work. Good work, guys.
All right. Yeah.
All right. Let's go after that market again.
Yeah. It's a team effort.
Yeah, isn't it always? All right, we're back. Let's do a couple of real-world samples because you can sit here and run CRMs all day long, but I think it gives a better flavor if you run some real samples, right?
Yeah.
So anyway, so Brendan brought some of his shirts and stuff down here.
Yep.
I'm just kidding.
A little small for me.
So let's see. So let's run a couple of things. Let's look at this. This is a little kid's shirt. We're gonna look at the buttons, remembering that what little kids like to chew on buttons, right? So let's just put it here with the camera. We can see when the button's right there in the field of view. Tuck that in so the thing interlocks. Shut this baby and hit start. So you can see we're right on the button by the beam spot indicator. So this comes up almost instantly, 2600 or so, high lead anyway. So high lead in the button, you know that in a few seconds, that's a fail. And that's a pretty serious failure because, like we said, that's high lead on the buttons and kids do like to chew on buttons. What else you got? You got some cadmium for us?
Yeah, so it got just another piece of kids' clothing. Has a logo with some paint on it, so we can test that, see what shows up in that.
Shoot the S.
Again, just, line it up.
All right. So you see you're hitting the S in the logo. Mm-hmm. Hit that. What do we got here? Let's see. We got very high cadmium. So it's obviously cadmium in the paint on the logo, 600 ppm. So again, regulatory limit's 100. So clearly above the action level. So there again, right? It's the logo. Kids chew on their clothes, their shirts all the time. That's the purpose of the regulation, was to get these toxic heavy metals out of a lot of these kids' clothes and shirts and toys. Anyway, so there we go. All right. Once again, there's some real world tests, just so you see. Again, great job. It's really nice software, very intuitive. Algorithm works great, so thanks a lot. All right. Portable benchtop by SciAps.